Okay, so on this first question, question 9, we are told that an aeroplane is leaving an airport and flies on a bearing of 70 degrees and travels for 60 miles. Okay, so what we're going to need to do is start to draw a very accurate diagram to try and illustrate what's going on in the direction this aeroplane is flying. So if we take a starting point, we take any bearing of travel from the north line. So we say that north is essentially a bearing of 0 degrees, and any bearing is then taken in a clockwise direction from there. So you need a protractor, and what we need to do is measure an angle of 70 degrees around this side here. So this is going to be a 70-degree angle. Now, what we then need to work out is the length of the line that we're going to need to draw. Now, we're told in the question that there's a scale factor of 1 centimetre to 10 miles. The line we're going to draw is a 60-mile line, so that's going to be a 6 centimetre line. Okay, and accurately, taking your starting point, you draw a 6 centimetre line on an angle of 70 degrees, drawing it 6 centimetres. Okay, so you would obviously have a very accurate diagram using a ruler and protractor. Okay, so this is then, after the first leg of the journey, this is where our aeroplane currently is. We're then told that it's then going to go on a bearing of 240 degrees for a further 100 miles. Okay, so that 100 miles is then going to give us the need for a 10 centimetre line. Okay, so that's going to be a 10 centimetre line, but this time on an angle of 240 degrees. Now, this is going to be a longer angle, obviously, and it's going to essentially go all the way around 240 degrees. Or if you're using your protractor, obviously, which goes up to 180 degrees, you're going to have to come back on the other side by 120 degrees, depending on how you want to do your line. So either 240 degrees clockwise or 120 degrees anti-clockwise, remembering always to come from the north line. Okay, but again, to get back to our diagram, we have to start where our aeroplane was after the first leg, and then we draw a 10 centimetre line going back at 240 degrees, 10 centimetre line. Obviously, your diagram will be accurate. Okay, and we then have the aeroplane here. Okay, so this is then a 240 degree line, 240 degree bearing with a 10 centimetre line. So essentially, what we're drawing is the first two sides of a triangle. Okay, which then gets us into what ultimately is question B and question C, the 2 points of the question we've got to answer. And the first question is saying, how far away is the plane from its starting point? And so what you need to do is, using a ruler, and assuming you've drawn the diagram accurately, be able to join the dots from where the line started, okay, to where it ended up. Obviously, you'll have a line in centimetres, okay, and you need to then convert that back to actual distance in miles. Now, assuming that you've drawn this one properly, when I did it, I got an answer of 4 centimetres. So that's actually going to give us an answer of 40 miles, actually, in terms of where that's actually going. Okay, and then you need to measure the angle between what's now our dotted line, again, our north line, and you need to measure this angle here. Okay, and then hopefully the answer, if you're drawing your diagram accurately again, will then come as a 50-degree bearing. Now, in key to answering these questions is bearings are always given in 3 digits. So even if the first number is a 0, we have to give the 0. So the bearing is 0, 50 degrees, with a line of 4 centimetres, ultimately giving us a distance of 40 miles when we scale it up. Okay.